today's class is about energy resources, which is part 2. We have already completed the part 1 and today we will start with the hydroelectric power. So, what is hydroelectric power? This picture shown in the slide is very much familiar to us. The dams and all. We are sometimes we are roaming here and there with the natural beauty of dams and all. So, this is hydroelectric power, and this uses water flowing down a natural gradient to turn the turbines to generate electricity. This is known as hydroelectric power. So, between 1950, that is 1950 and 1970, the hydropower generation worldwide, it was increased 7 times. The long life of hydropower plants, the renewable nature of the energy source, very low operating and maintenance cost, and absence of inflammatory pressures in fossil fuel are some of the advantages of this kind of hydroelectric power. So, this hydroelectric power is also having some drawbacks, because first one is a large area. It will need a large area. Many times some areas of forest and agricultural lands, they are submerged with this kind of hydroelectric power plants. So, these lands traditionally they are provided a livelihood for the local tribal people and the farmers. So, there are some conflicts over them because we are taking their land or their things from them for generating the plant. Next, it is silting of the reservoir. Silting means nothing but deposition of some sands or rocks or the things like this. So, this kind of things reduces the life of the hydroelectric power installation. If this kind of depositions will be happened, so the main source, that is water, the force of this water will be reduced. So, in that case the hydroelectric power may not work properly. The next one is water is required for many purposes. We all know this, that water we need in many purposes, maybe domestic use, maybe the growing agricultural crops, maybe for industry. So, for this kind of situation, when we are using hydroelectric power, we need a gallons and tons of water. For this reason, the water for our other uses may come to in a very low way. So, the use of rivers for navigation and fishing becomes difficult once the water is dammed for generation of the electricity. And also the resettlement of the displaced person is a problem for which there is no ready solution. So, the opposition to many large hydroelectric schemes, it is growing as most dam projects and that has been unable to resettle the people were affected and displaced. And also one point is there that in certain regions this kind of dams, they can produce the earthquake, that means the seismic activity. This is a great possibility of this occurring around the Tehri Dam and Himalayan foothills. So, there are this kind of situations where earthquake happened suddenly for this kind of hydroelectric power. So, with large dams causing the social problems, there has been a trend to develop small hydroelectric generations also. Some small kind of hydroelectric power generation units are there, and in many countries they are using, mainly China. This is having largest number of 60,000 and generating 13,250 megawatts. So, 30% of China's electricity, and not only China, Sweden, US, Italy and France, they are also having the developed small dams for the electrical power generation. So, the development of this kind of small hydroelectric power units can become very important for important source in India also. So, this kind of steeply falling rivers and economic capability can be grown from this kind of hydroelectric power. So, next we will go for the solar energy. So, in 1 hour the sun pours as much energy onto the earth as we use in a whole year. Can you imagine? So, if it were possible to harness this colossal quantum of energy, humanity would need no other source of energy. So, we don't need no other source of energy if we can use this energy in a full way. So, today we have developed several methods for collecting these energies, this solar energy, and some methods are very much familiar to us because we can see many plates that are the solar plates. So, these are installed in many ways. So, one is solar heating for homes. So, modern housing that uses the air conditioning or heating are extremely energy dependent. So we need a large amount of electricity for running those air conditioning or any kind of things like this. So a passive solar home or building is designed to collect the sun heats through the south facing glass windows. In solar heated buildings, the sun spaces are there. So in this slide we can see the sun space. What is the sun space? They are built in a way that the floor or the wall or the bricks that will absorb the heat throughout the day and release the heat when it is cold. That means at the time of night it will release the heat. So it is a very good idea for having these kind of things. Energy is also this sun energy, that means heat, that water and wind are also used to heat the building when the weather is cold and too cool it in summer. So this is based on designing and building material. We know this is also very familiar to us that some stone made buildings are there in many of the rural areas, and also the mud hut we can see in our village areas also in West Bengal, that many things, that means mud hut that is made of mud. These kind of buildings, they are having a natural thing, that means it will have the cold nature when it is summer and it will be hot at the time of cold. Small doors and windows are kept direct sunlight and heat out. So deeply set glass windows in colonial homes on which the direct sunlight could not reach. And also cross ventilation, we can see in the third picture in the lower portion of this slide, the cross ventilation. What is that? I have also already told in the class that cross ventilation is when we are actually allowing the air to pass from one side to another. So this cross ventilation will not cause any kind of suffocation inside one room, and it will make the room cool also. So large overhangs over the windows prevent the glass from heating the room inside. So double walls are also sometimes used to prevent heating, and shady trees, that means the trees which can give the shade around the house, will help reduce the temperature. So these are the main things to be known. Next we will go for solar water heating. So most solar water heating systems, they are having the two main parts, that is collector and storage tank. The solar energy collector heats the water which then flows to a well insulated storage tank. A common type of collector is the flat plate collector. That is a common type of collector. This is flat plate collector. So we can see in the slide also there is one plate. This is called flat plate collector. This is a rectangular box with a transparent cover, and it will face to the sun, usually mounted on the roof. Small tubes are there. We can see in the picture also there are some tube like structure, just like our tube light. So these kind of tubes are there which will run through the box and carrying the water or the fluid such as antifreeze, any kind of fluid which is not freezed. This kind of fluid will be there. The tubes are mounted on a metal or absorbable plate which is then painted black to absorb the sun's heat. The back sides of the boxes are insulated to hold the heat and builds up in the collector. So as the fluid passes through the tubes, it too heats up. So solar water heating system cannot heat water when the sun is not shining. So thus the home must also have the conventional backup system, because when it is cloudy, then we will not be able to have our water heated. So this is not done. That's why this kind of systems must have some backup system, so that in cloudy environment also, when the environment is cloudy, when it is raining or there is no sun for a daytime, so at that time we can have the energy as well as the backup power is there. So next we will go for the solar cooker. So nowadays we can see in many more sites and also in social networking site that solar cookers, they are having a growing demand. So why? Because this cooker is so much environment friendly that this will not need any kind of fuel or gas or anything. It will only use the solar energy to cook, and it will not produce any kind of pollutant, because it is only using the heat of the sun and it is cooking. So this solar cooker is a metal box which is black in color and inside to absorb the return heat, because we know already that black color is the color which will absorb the heat most. the lid is having one mirror. We can see in the picture also the lid, it is having one mirror. So this mirror will reflect the heat from the sun into the box. The box will contain black vessels in which the food to be cooked is placed. We can see in the picture also that in the first picture we can see that in a black vessel the food is cooking. Why this is also black? Because this will also absorb the heat as well. India has the world's largest solar cooker program, and estimated 2 lakh of the families that are using solar cookers. So this is a very good news for us, and although solar cookers reduce the need for fuel wood and pollution from smoky wood fires, they have not caught on well in rural areas as they are not suitable to traditional cooking practice. Because we are having some traditional cooking practice, we know we are having woods and we are having leaves and we are cooking in this way. Though it is having so much of pollutants in the air, we may have so many problems, maybe lung problem and like this, but also as it is the traditional form, so we are using this now also. Now we will go for the solar desalination system. This is nothing but the system which will convert the brackish water, that means the water which is saline, into distilled water. So this is also a developing form, and this has been developed also. In future it will become important alternative for man's future economic growth in the areas where the fresh water is not available. So we know in many areas like delta areas or the mangrove forest areas, they are having the only brackish water to drink also. So in this kind of area we can have this kind of distillation unit where we can produce distilled water or the water without the saline or the salt. Now we will go to the photovoltaic energy. So the solar technology which has the greatest potential for use throughout of the world, this is the photovoltaic cells. This is very familiar to us because the solar light, the sun's light, it is not, if it is heat, it make electricity. The PV cells or the photovoltaic cells, that I will say PV cell, that will require a little maintenance. It is having no moving parts, and essentially this is having no environmental bad impact. They can work in a very clean way. And also this is very important fact that when the light hits the cell, the charges begin to move between the two layers and the electricity is produced. What is that? This is also can be installed very quickly in a small module anywhere there is sunlight. Solar cells are there, and it is having two separate layers of silicon. Each of these contain an electric charge. So whenever the light will be coming, it will hit the cell, the charges begin to move between these two layers and electricity is produced. So this is a very similar and very simple way to produce electricity, but it is also a very important way so that we can have electricity anywhere. And PV cells are wired together to form a module. A module of minimum 40 cells, that is enough for power a light bulb. Just think about it, only 40 cells, that is enough to light a bulb. So this kind of solar energy we can see anywhere in our street light also. This is having also in a rural area, it is also extensively growing, and it is having increasing efficiency, extending the cell lifetime. Many new materials such as amorphous silicon are being tested to reduce the cost, because it is cost effective. It is not cost effective, I'm sorry, it is not very much cost effective because it is a costly a bit. So that's why many more people are not using. So in the street light and many more things, this kind of photovoltaic energy we are using. We may also have the calculator and the watches of the PV cells. They also provide the power to satellite, electric lights and small electrical appliances such as radios, and for water pumping, highway lighting, weather stations and many other things. So these are the cells that are environmentally benign. They do not release pollutant or any kind of toxic material to the air or water. So there is no radioactive substance and no accident, no kind of accident. So some PV cells, however, do contain small quantities of toxic substance such as cadmium is there. These can be released to the environment in the event of a fire. So solar cells are made of silicon, which will generally, although the second most abundant element in the Earth's crust. So these solar cells is very much growing need also. Now also we are having very much growing need. Now we will go for the solar thermal electrical power. What is this kind of power? This solar thermal electrical power, or STE, it is the 20 years behind the wind energy market exploitation, but this is also expected to be grown rapidly in near future. We can see in the slide there is having one mirror energy. So during the 1980s, a major solar thermal electrical generation unit was built in California containing 700 parabolic mirrors, each with 24 reflectors. Each was 1.5 meters in diameter, so which focused the sun's energy to produce the steam to generate the electricity. So this is also one kind of growing need, and we should go for this kind of solar energy so that we can use it properly. Now we will go for the biomass energy. What is biomass? When a log is burned, we call this as a biomass energy. Whatever we are burning, the biomass sources, that means we can see in the slide the forestry crops or the animal residue or the sewage, these kind of things we can call the biomass energy. So because plants and trees, they depend on the sunlight to grow, the biomass energy is a form of stored solar energy, because we know that all the plants, they are storing the solar energy within. So there are three ways to use the biomass energy. It can be burned to produce heat and electricity, changed to a gas like fuel such as methane, or changed to a liquid like fuel. So liquid fuels also called the biofuels, which will include two forms of alcohol, that is ethanol and methanol. So because this biomass can be changed directly into the liquid fuel, it could someday supply most of our transportation fuel needs for car, trucks, buses, or many things that we are transportation system we are having. So this the diesel maybe also can be replaced as the biodiesel, which is made from vegetable oil. In United States, this fuel is now being produced from the soybean oil, and researches are going on, and also researchers are developing some algae to produce the oil, which can be converted to the biodiesel. So this is also one very much interesting fact. Now the organic or municipal solid waste, this will include what? The paper, food waste, and other organic non-fossil fuel derived materials such as textile, many rubbers or leathers. These are called the organic municipal solid waste. So currently in United States, the approximately 31% of organic waste is recovered from municipal solid waste via recycling and composting program, and 62% deposited in landfills, and 7% is incinerated. So like any fuel, biomass creates some pollutant. These kind of things can create some pollutants, including carbon dioxide, when it is burned or converted into energy. So in terms of air pollutants, biomass generate less relative to fossil fuel. So this is naturally low in sulfur, and therefore when it is burned, it will generate low sulfur dioxide emission. However, if burned in the open air, some biomass feedstocks would emit relatively high level of nitrous oxide. So this is also a important fact for any kind of biomass. Now we will go for biogas. What is biogas? This is produced, as we know, cow dung can produce biogas. In rural areas, it has been extensively used, cow dung as the biogas. So it is produced from plant material and animal waste, garbage, waste from households, and some types of industrial waste such as fish processing or dairies, maybe sewage treatment plants. So it is a mixture of gases which includes methane, carbon dioxide, hydrogen sulfide, and water vapor. So in this kind of mixture, methane burns easily. With a ton of food waste, one can produce 85 cum of biogas. So once used, the residue is used as the agricultural fertilizer. So biogas plants have become increasingly popular in India and in also rural sector. We know that also that in rural areas of India and also in West Bengal, we are having increasingly popularity of biogas. So they are using cow dung, which is converted into gas, and it is very much available in rural area. It is also used for the running dual fuel engines. The reduction in kitchen smoke by using biogas had reduced and lung condition in thousands of homes. So the fibrous waste of sugarcane industry, that is also the largest potential source of biomass energy. That ethanol produced from sugarcane molasses, it is a good automobile fuel, and it is now has been used in the third of the vehicles in Brazil. So, National Project on Biogas Development, that is NPBD, and Community Industrial Biogas Plant Program promote various biogas projects. In 1996, there were already 2.18 million families in India that used biogas. However, China has more than 20 million of families which are using the biogas as the fuel. Now we will go as in the wind power. We can see in the slide what is the windmills can be seen like this. So, wind is the earliest energy source used for the transportation by sailing ship. We all know in history also we know that the ships has been transported through the winds. Some 2000 years ago, windmills were developed in China, Afghanistan, Persia to draw the water for irrigation and grinding grain. So, most of the early work on generation electricity from wind was carried out in Denmark at the end of the last century. So, today Denmark and California have the large wind turbine cooperatives which sell the electricity to the government grid. In Tamil Nadu, there are large wind farms producing the 850 megawatts of electricity. So, at present, it is very much proud things for us that India is the third largest wind energy producer in the world. This power in wind is a function of the wind speed, and therefore the average wind speed of an area is an important determination of economically feasible power. So, wind speed increases with height at a given turbine site. The power available 30 meters above ground is typically 60% greater than 10 meters. This is having some environmental impacts which is very few, but it is having that the principal problems are birds may be killed, noises are there, and maybe some effect on TV reception and aesthetic objects through the sheer number of wind turbines that require to meet some electricity needs. Also, it is also a thing that a large area is needed for this kind of wind farm. So, the amount used by the turbine bases and foundations and the access road is less than 1% of the total area covered by the wind farm. So, these are the things which should be reminded about the windmills. Now, this is my references, and thank you for listening to today's class. We will go back again